Welcome back to Geometry Chapter 7, Section 2 in this book. But you can learn this concept even if you're not following this book and you're following some other book. We're going to be talking about reflection. So we talked about last time that what we're doing is we're moving figures around a piece of graph paper. And they're all called transformations. So a reflection is a type of transformation. And we talked about last time that it is like flipping something over another thing, like flipping it over a line. And last time we did this with shapes, the shape of the letter F, and we flipped the F over the line. And now we're going to talk a little bit more of things you can flip over stuff. All right, so one of the things you can do is points. I have this point P that is the pre-image, and I can flip it over line M, and there is the image. Now, if you draw a line between the pre-image and the image, it will be at right angles. It will be perpendicular to the line. So line P prime, that line, is perpendicular to line M, this line. So we flipped it over. Okay, here's another one. P and P prime are actually the same point, and they're on line M. So why is that a reflection? Because how's it flipping if it's its own self? Is it just somehow spinning on its axis like a globe? Is that what it's doing? You can imagine it that way if you want. The reason why you do that is sometimes you'll have a figure like this that you're flipping over a line that goes through that figure, so those points are actually still. So instead of there being a space between the figure and the line it's flipping over, it's actually touching that line, so those points just rotate on that line. P to P prime, they're the same thing. So P equals P prime, they're the same point on line N. And that's why you have that. Not just to confuse you, I promise. Okay, so here's a theorem, and it says a reflection is an isometry. Remember, iso means same, and isometry means it's the same shape with the same size. So, when we talked about last time that these transformations were isometries, that we're moving shapes around, but we're not changing their size or shape. Later on, we will talk about things where they're similar and they are different sizes, but the same shape. But right now, everything is same size, same shape, okay? Now, here is a problem. They want to do two things on this one piece of graph paper. Here's my y-axis. Look, I wrote y again. Doop, doop, doop. Sorry about that. There's the x-axis. There, that looks better. And the first thing they want to do is they want to take the pre-image, this dot, of h at 2, 2, meaning you go out 2 on the x and up 2 on the y, and they want to flip it, they want to reflect it over the x-axis. So we go woo, boom, and where it would land, it has to be the same distance from the line to flip it over, and where it would land is at 2, negative 2, it just flipped over. And notice that this is a right angle, just like it's supposed to be. And next they said to flip G at 5, 4 over y equals 4, but it's on y equals 4. So G and G prime are the same thing. Yeah, it's 5, 4. It's the same point. It's that situation. All right, so don't be confused by that. Do you remember how to do y equals 4? Remember, if you have the line y equals 4, you go on the y-axis up to 4, 1, 2, 3, 4, and you put a dot, and you say no matter what, x can go up or x can go down, but y equals 4. It's confusing because the line y equals 4 is horizontal, but the y-axis is vertical. But if you say no matter what, it helps. All right, so here's some other ways we can flip things. More flipping. Okay, so here I've got line PQ, and I'm going to flip it over this black line. It probably has a name in the book. What's the name of the line? The line is named M in the book. So I'm going to flip it over M to P prime, Q prime. So I pick it up and go whoop and flip it over, like turning a page. So you can see that P went to P and Q went to Q. And you can also see I did a bad job drawing it because it doesn't really look like the right angles that they're supposed to be. But if you look in the book, they draw really good. All right, so here's another one. I got the blue line PQ, and I'm going to go like this, whoop, and flip it that way. So P goes over here to P prime, and Q goes over here to Q prime. So it goes whoop. You're turning it like that. As this one flips to there, and that one flips to there. So the two ends of it are going kind of opposite. It's like taking a baton and going flip over. So P goes to P prime and Q goes to Q prime. That one I did better. Those look pretty perpendicular. Okay, this one, P and P prime are both on our line M. So just the Q flips around. It goes woo and flips around because this one is like it's stuck down and just that one can move over. Here you've got P, Q, Q prime is on M, so it's going to stay still, and there you've got P prime. I always think of those things. You remember those things you get at the like Halloween fairs and stuff, and it's got a stick, and it's got two sticks with balls on the end, and you go click, 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 and the balls swing around, and click, 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 click. You might not know what I'm talking about, but that's what I always imagine that is. It's the two balls on the stick, you go like this, and they swing around, click, 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 click. And I've only gotten those from like church fall harvest festivals at Halloween. All right, so symmetry means you're dividing a shape where it's the same on both sides. I am symmetrical. I have one line where you could cut right down the middle and the two sides would fold in on top of each other and be the same. So I have one line of symmetry. If you cut me this way, then the two sides are not the same. They're different. There's a picture in the physics book I teach where they've got this Barbie doll where they've got her reflected like the wrong way, and it's freaky looking to have her symmetrical the wrong way. It's like, why did they do that to the Barbie doll? Don't even remember. All right. So how many lines of symmetry are in this shape? There's only one. We can cut it down the middle right there. Any other way you cut it, it would not be the same. How about this one? It has two lines of symmetry. It's got one going this way and one going that way. If you do this side, those two are the same, this side, these two are the same. And this is supposed to look short and those long. You can look in the book and see a better drawing. This one's supposed to be the same all over, like a stop sign. It is a hexagon. And let's see its lines of symmetry. We can divide it on the pointy parts, the vertices. One, let's go here. 2, 3. I did 8 side things. 1, 2, 3, 4, 5, 6, 7, 8. I drew the wrong figure. I did 8 sides with 8 sides with 8 lines of symmetry. If you want to see the right one in your book, the 6-sided figure, they did better drawing it than I did because they drew the right figure. Only has 6 lines. I guess I should do it for you. Let's try it. Let's draw a stop sign the right way. It's doot, doot. 1, 2. You gotta go. 3, 4, 5, 6. Okay, that's a terrible stop sign, but at least it's got the right number of sides on it. Doop, doop. Okay, so now let's do the 6 lines of symmetry here. You can go through the points. 1, 2, 3. You can go through the flats. 1, 2, 3. 6 lines of symmetry. Okay, so like on the test, you look at lines of symmetry and flags. So make sure you do your homework. Make sure you understand the symmetry. It's also pretty. This is the prettiest chapter in the book with all of this symmetry stuff. Look at the word problems, read over them, make sure you understand the lines of symmetry. Sometimes they're really reaching for it when they're looking at snake skins and stuff like that. Those patterns, flowers, they're not quite as symmetrical as they act. But anyway, they're still fun to look at and pretty, and there is symmetry in nature. Math is great. See you next time.